another really fun integral here. But yeah, to start, because our given integral is cumbersomely written, let's rewrite it in a friendlier form, and that'll look as follows. And it's fairly straightforward algebra to show that what I'm about to write is equivalent to the given integral, and that is x squared divided by x squared plus 1 times tan inverse x dx. Now, what we have to do here is integration by parts. And so we'll pick u to be tan inverse x, and that'd mean du is 1 over 1 plus x squared dx. And so then our choice of dv will have to be x squared divided by x squared plus 1 dx. So then v will have to be the integral of what I just wrote, and we need some space. So v will have to equal integral x squared divided by x squared plus 1 dx. And to deal with this, what we're going to do is add 1 and subtract 1 from the numerator. That way we're able to rewrite v as integral of x squared plus 1 divided by x squared plus 1 dx minus integral of 1 divided by x squared plus 1 dx. And so here, notice that that's just 1 dx, and so that's just going to give us x, and what we have over here is going to be tan inverse x. So we've got our v just now, we have u, and then we have dv. So I think we're able to write the other side of the integration by parts equation, because here we have u dv, and so we know that's uv minus v du. So let's rewrite, or let's write the right side, uv, which is tan inverse of x, times v, which we just found out to be x minus tan inverse x. I'll have to write tan inverse x a lot in this video. And then minus the integral of v du, right? Okay, so v is x minus tan inverse x. And then obviously I need to make some room. Let's do that. Lasso. All right. So v and then du, right? And du is where? Right here. So that's times 1 divided by 1 plus x squared dx. Got it. Now we no longer need the blue stuff, so let's get rid of it. Cool. And what do we have left to do here? Well, we have the following left to do. First, let's distribute the tan inverse over here and write that we've got x tan inverse of x minus tan inverse of x all squared. And then minus this integral, let's write as two separate integrals, this one giant integral here. And we can do that while also distributing this to both of these guys. So we're going to get minus x divided by x squared plus 1 dx. And notice minus minus is going to make this last term we're going to write a positive. So plus integral of dx divided by 1 plus x squared times tan inverse x. And that is that. Now, let's say that this integral is called a. And that's going to be the only hard part left, because this is just simple u substitution. And in fact, with just simple u substitution, we could write that this integral right here is 1/2 the natural log of absolute value of x squared plus 1. Yeah? Cool. And therefore, we can do this. Get rid, slide into place. Cool. And so then, like I said, all we'll have to do is work on a, and then we're done. Yeah? Cool. So a, notice, and let me write in black or a different color. So a, notice, which is this, is going to require integration by parts again. And this time we're going to say u is, well, not this time, last time, originally also we picked u to be tan inverse. So yeah, we're going to do the same here. I pick u to be tan inverse. So du is going to be 1 over 1 plus x squared dx. And then let's pick dv to be dx divided by 1 plus x squared, so that v is going to be tan inverse x. So then by the integration by parts formula, a is going to be uv, which is tan inverse x times tan inverse x, therefore tan inverse x all squared, uv, and then minus, see, I wasn't joking about having to rewrite tan inverse so many times, uv, or to write it, not rewrite it. Anyway, yeah, so tan uv minus v du, and v is tan inverse, okay? And then du is dx divided by 1 plus x squared. And so with just the commutative property, one can realize that this and this are the same. So this last thing that I just wrote here, this integral that we have left to work out for a, is actually equal to a. And so then instead of writing all this junk, I could delete it and replace it with a. And I will. When I do that, notice I could add this a to both sides and write that I have 2a equaling tan inverse of x all squared. That'd mean that a is equal to 1/2 tan inverse of x all squared. So cool. That's what I'm going to do here. Get rid of this, since we just found out what it is, and write in red that it equals 1/2 tan inverse of x all squared, and finally plus c. Yeah? Cool. Now, before we finish, we notice that this guy here and this guy here are like terms, and they combine into a negative 1/2 tan inverse x all squared. So if you do that, you should be able to find the final answer, which I rotated unintentionally right there. Yeah? Cool. All right. I hope you enjoyed this, and keep watching. Take care.